everyone, I am Ayush Gupta and currently I'm a Design and Verification Trainee at Pine Training Academy. So today I'm back with another video on a very useful and common topic among VLSI aspirants, that what is the best approach to learn Verilog, right? So let's start with the video. Okay, so before jumping on to the approach to learn Verilog first, let's look at what is Verilog and what it does, right? So in my time when I started learning Verilog, I was also pretty much confused, like you guys, where to start and when to start, what are the resources to learn Verilog and all. So I also read many Quora answers and I wasn't satisfied at all. So I figured it out myself, and that's what I will be telling in this video. And at the end of this video, one shall have a very clear understanding of like how should they approach uh, to learn Verilog efficiently, right? So what is Verilog? Basically, like most of you guys must be very well versed with the full form of Verilog HDL, right? It is Verilog Hardware Descriptive Language, right? So as the name suggests, hardware descriptive language. So it it basically synthesizes a hardware based on the Verilog code you have written, right? So Verilog is used for like getting um, synthesizing hardware based on the Verilog code as well as emulating them. Okay, so we'll get on to emulating part later on. So as of now, you must be clear that what is Verilog and what Verilog does. It is not a computational language or a development or a language used for development purposes like Java. Okay, it is like the concept is same, right? And the purpose of this language is different from the other programming languages that you might have heard of, right? Now, you all must be clear with what is Verilog, right? So, in layman terms, it creates hardware, or you can say digital circuits based on the code you write in Verilog, right? So, the next question is, are there any prerequisites to start learning like Verilog? So, the answer is yes. Um, a much needed thing is you must be very well versed with digital electronics, right? So as we have seen, right, Verilog creates digital circuits. And how do you design digital circuits? By using the concepts you will learn in digital electronics. So before jumping on to Verilog, please ensure that you are like digital electronics is in your blood, right? And you are very well versed with all the concepts like combinational circuits, sequential circuits, FSM. Okay, so then it will be easier for you to understand the concepts of Verilog, and like you can start creating basic digital circuits on Verilog, uh, and you can simulate them as well, right? So the next thing is how one should learn digital electronics, right? What are the resources? So in my previous video, I shared um, like standard resources to learn digital electronics, right? You can refer a book by Maurice Mano and um, Digital Electronics by Anand Kumar. Okay, so start learning from very basics, right? From gates, flip-flops, registers, counters, multiplexes, demultiplexes, and like further combinational and sequential circuits to FSM, right? Both Mealy and Murray FSMs, and you will be good to go with Verilog. Or what you can do is you can learn all the things side by side, right? Like what you can do is you can like today you learned a circuit that resembles adder, okay, and next thing you can do is design the same thing on Verilog, right? So you will learn implementation as well as like the basic theory of it. right? So what it will do is it will build up your concepts and like you will see a clearer view of what idea is and how to implement it, right? Yes, so now let's look at the steps. So let's suppose we are done with our digital concepts. So step number one is done. And the next step is like from the day when just refer to the Samir Palnetkar's book, right? Verilog HDL by Samir Palnetkar. And just for starting off with Verilog, start with the NPTEL's Verilog course. Okay, so the professor has very well explained the working of Verilog, basically how it constructs the digital circuits by reading the code. So it will give you a better understanding like how Verilog works, right? So for starting purpose, you can uh, start with the gate level modeling, and you can try to model some basic digital circuits, right? Like adders and subtractors, or basic flip-flops and all, or even registers too, right? So you can start by gate level modeling, and later on you can move to behavioral modeling or data flow modeling, right? Also, side by side, you have to learn some tools like Xilinx ISE. I also started by using Xilinx ISE because it is very user friendly, and later on I switched to Xilinx Vivado. Okay, but I will strongly recommend you all to use Xilinx ISE uh, as it is a very a beginner friendly tool basically. Okay, and on top of that, it is free, right? Xilinx Vivado is free, like a basic edition, till a basic edition, and Xilinx ISE is free to use, or you can use Model Sim also. And just in case, if you don't have any of these, then you can um, practice Verilog on EDA Playground. We'll get on to that later on. So these are the basic steps that you have to follow. Also, it is my sincere advice to all of you that please keep um, digital electronics book side by side while you code um, any circuit on uh, Verilog, right? So what it will help you in, like you will get to revise the concept side by side, and both your Verilog and digital electronics will become strong, right? So while referring to the video course and the book that I just recommended, so you will come across many data types in the beginning and the different types of modeling, right? So what you have to do is like go in the very depth of uh, each and every data type. Like you will come across wires, registers, integers, bits, bytes. So like go in very depth of it, and like by the depth I mean like you should have the knowledge of what is the default value of each and every data type and how it is different from the other, right? Is it signed by default or unsigned by default? So you have to understand that, and all the knowledge you will get from the book, and just in case there is something lacking, so what you can do is Google each and every topic separately, right? And while you will learn different types of modeling, you will come across blocking and non-blocking statements. Okay, and you have to. It is must to understand like what is a blocking statement and what is a non-blocking statement. And for that, I shared a very like famous resource like in my previous video. Please refer to it. Okay. And the very next thing you will come across is non-synthesizable and synthesizable constructs. These are basically I discussed in the beginning of this video. Like Verilog can be used to design the digital circuits as well as simulate them, right? So, Verilog basically, in simple terms, can simulate a digital circuit, okay, and design a digital circuit. So, for designing circuits, we have to use the constructs which are synthesizable. Okay, in Verilog there are two type of constructs like synthesizable and non-synthesizable. The constructs which are non-synthesizable cannot basically produce a digital circuit, right? As it is not synthesizable. So you'll have to be very clear that which construct you will have to like use in your Verilog code, because and the ultimate goal of a designer is to produce a digital circuit, right? So for that you have to use synthesizable constructs, and for using synthesizable constructs you will have to be very clear like which construct that you are using is whether it is synthesizable or not, right? So, in simple terms, non-synthesizable constructs are those which are used for the simulation purpose, basically for writing test benches, right? Like, for example, loops or initial statement, right? So that's all. Like, my advice is to all of you guys is that please give time to the basics, right? So after following all the three steps correctly, the next thing that is important is practicing, right? So for practicing, you can follow the exercises given in the Samir Palnetkar's book, and it is more than enough. For additional practice, you can refer to the website called HDL Bits. There's an ocean of problems properly categorized, and this will basically um, make your concept stronger. And it is advised that you practice from this website, and it is just like uh, Code Chef and Geeks for Geeks. The last and the final step is try to work on some projects. Start from the very basic ones like sequence detectors, traffic light controller, and then advance the projects, and you can design a 4-bit sign calculator or uh, automatic washing machine controller or something like that, and that's all. You are ready to crack the interviews, right? And also don't forget to practice the interview questions side by side, and that's all, and you'll be good to go.